Hi, today we are going to discuss about an interesting topic on how to automate an Electron application using Selenium WebDriver. So before jumping into it, we need to understand what is Electron. Electron is a framework for creating a native application with web technologies like JavaScript, HTML and CSS. So basically it is a combination of Chromium and Node.js. So as you all know, Chromium is an open source browser and Node.js is an open source server-side runtime environment which is built on Google Chrome. So after Electron comes into the market, many companies started using Electron. For example, WhatsApp, Slack, Skype, these companies started using Electron for their desktop application. So why people are going beyond Electron? So I will share my own experience why we started using Electron. So initially in our organization, we initially started using Zool. So when we started using Zool, when there are so many requests which comes from the client side, we were unable to satisfy those requests because the customization which you can do on Zool is very limited. We cannot do so many customizations on Zool. So then we switched from Zool to Node WebKit. So Node WebKit was going smooth, and after some point of time, they gradually decreased their development and support. So after some point of time, we were unable to do we were unable to develop more uh, request on Node WebKit. Then we switched our focus from Node WebKit to Electron. Since many started using Electron, we would like to try our hands on Electron. So Electron were giving so many features which we can do, where we can do so many customizations, and their support was pretty good. So that's why we switched our focus from Node WebKit to Electron. Okay, all these development stuffs were very good at Electron, but always when it comes to the automation for the desktop application, it is really a big challenge when compared to the web application. So there is always so many challenges which we face while automating an desktop application. These are the major challenges which we face while automating a desktop application. So when you go for uh, automating tools for desktop application, you can find very less open source tools. Yes, there are so many tools which open source tools available, but all those tools are less efficient. It should be efficient as well as it should be open source tools. It is very less, I would say. And when you come to the resource, for example, you can there are so many tools which are available in the market, but when you want to try your hands on it, the less resource will be available. So resources, I mean, I'll do some automation. So I will stuck up at some point where I need to continue from that point. So if I look for some resource how to continue from that point, the resource will be very less, so that I'll be stuck at that point. I could not continue from there. And since the resource is also less, the support will also be less. Since it is open source, we cannot get that many support. And there are some tools which is OS specific. For example, AutoIt. If you take AutoIt, it is applicable only for Windows. There are some tools which is applicable only for Mac. There are some tools which is applicable only for other OS. And one more major challenge is accessing the native window. So this is also a problem in web application as well, but accessing a native window is one of the biggest problem while automating a desktop application. So these are the major challenges which I would say in automating a desktop application. So I, in the coming slide, if you see, there are many tools available for automating a desktop application. For example, first one is Seculi. So Seculi is basically an image recognition tool. So when you record something, when you capture the image of something, and when you automate it to look for the image, if the image is there, it will do all this own process. But what if the image is getting changed? We are stuck at that point. So next one is AutoIt. So AutoIt is nothing, it is, I would say, it is one of the efficient open source tool in the market right now. But as I said before, it is applicable only for Windows. You cannot automate with Mac. The Spectron is something which is one which can be automated with only with Electron. So when we tried our hands on Spectron, there are so many disadvantages, and we cannot do so many things with the Spectron. As I said before, there is less resource and less support available for Spectron since it is only applicable to Electron. So there are less support and less resource available for the Electron. So UFT and test plan, which is very efficient. Yes, I agree, but end of the day, it is not an open source. UFT, as you know, it cost much, and test plan as well. So these are the disadvantages. I would not say it is a disadvantages. It is a challenges which we face finding tools, efficient tools while automating an desktop application. So coming into the web application, all these things which I mentioned with the previous slide, all these things can be satisfied with the Selenium. Whatever the drawbacks which I mentioned with Securely, AutoIt, Spectron, UFT, everything can be satisfied with this Selenium. So Selenium, as you all know, it is a open source, one of the most efficient functional testing tool is Selenium. And there are so many tools which are available in the market, open source, but Selenium is one of the finest tool which I have come across. So now today, people might think, why can't we have a Selenium WebDriver in desktop application? Yes, that is what we are going to discuss today. We can automate a desktop application with Selenium WebDriver, but there are certain conditions which apply for it. So we'll be explaining on how to automate an Electron desktop application using Selenium WebDriver.
Yeah, before jumping to Electron, let's see how does browser automation works. Let's take an example like if you want to start a Chrome and open Google on it, so we need three things basically. First is WebDriver, and then Chrome driver, and then browser. What is WebDriver? WebDriver is a cross-browser automation API that API covers browser controls and like navigation and user simulations. So the APIs covers good things, and these APIs are implemented by the browser, and the result is we have a Firefox driver, Chrome driver, Safari driver, Internet Explorer driver. So the list goes on. And last we need Chrome browser. Sometimes I used to get a question from people like whether Chrome browser is needed to automate Chrome. So basically we use Chrome driver. Why do we need Chrome browser? But the answer is yes. We need Chrome browser when you want to automate Chrome, uh, because Chrome driver expect Chrome to be installed on your system on its default location. And now let's see how this three communicates with each other. Uh, Basically, WebDriver is a client and Chrome driver is a standalone server. So this both communicates through WebDriver protocol. So and Chrome driver communicates to the Chrome browser through DevTools. Um, so yeah, to do now let's see the uh, code snippet how this works. So this code is written on Java. Let's see what happens when you execute these statements. So this basically does it starts a Chrome and opens Google on it. So when you execute this line, the first thing it will start the Chrome driver server on a free port, and then to start a Chrome instance. So basically, it's in a WebDriver as a client. So it just creates the it just constructs the URI equal the equal URI for an Selenium command to which it needs to hit the server, and it considers the payload JSON. So in case of creating a new instance, it will hit the session URI. So now what happens is it will start the Chrome instance. So now the next line is to get Google loaded on it. For this, it will construct the equivalent URI, and it will consider the payload JSON. For this, it will be like a simple JSON, like the parameter will be the URL and with the Google. And then it communicates to the Chrome communicates to the dev tools to load this. So now let's see how Electron automation works. To do the same thing, like to load the Google on Electron. So what are things that we need? The same things that we need for browser automation. That's what basically we need. But instead of browser, we are going to use Electron. That is the only difference we see it in Electron automation. So, but the question here is how we can ask Chrome driver to communicate to Electron. So for this, we're going to make use of the feature remote debugging of Chrome. So basically, when you can start your Chrome instance in a remote debugging port through this command in your command line. So when you start this, your Chrome instance on this mode, basically it will detach the Chrome dev tools from that particular Chrome instance, so that you can remotely debug your application that's loaded on that particular Chrome instance. So how you can debug is how you can see the web applications or web pages that's loaded on that Chrome. You just needs to you can just need to eat the port with the localhost. So wherever if you're running in your local system, you can use your localhost or your IP address. If you use this, it will list out the pages that's loaded on that particular Chrome instance. So, and then if you click on each page, you can inspect it out. You can basically debug. The same thing we're going to use it for. The same thing we are going to use it for Electron. So, basically Electron is a combination of Chromium and Node.js. So, this gave us path to automate Electron. So, the same way as you started for the Chrome, you can start your Electron application in the same remote debugging port. The same line you can use it out. So only thing you need to do is you just need to change the path of your instead of having a path of Chrome, you should have your path for Electron. So once you do this and once you start your Electron application, so you need to ask the Chrome driver to communicate to the that particular port. So to do this, we're going to make use of Chrome options and desired capabilities. So in Chrome option, we're going to make use of one method set experimental options with the key value parameter with key as a debugging address, and value you're going to set the set the uh, that IP address with the port. So once you do this and start your Chrome driver with these capabilities, you can start communicating with your Electron. So let's see a small demo on that. So yeah, so before that, let me start our application Electron. This is a Electron application that we use internally in our office. So I have started the Electron application. Now, let's start the code to that communicate. So yeah, basically I'm just opening my Google on that Electron. So I'm just asking I have passed a local where to communicate. So you guys wonder like how I doing this, because um I didn't start it from command line. So in case of our applications, we have a we have hard coded that port number, remote debugging port number in the application itself. Some we do it for debugging purpose for developer as well as a tester. So in case of if you in case of the in this, if you try to start your applications with your own debugging address, but it will rewrite you the port number which is be given on the application, which is given in the application. So it's to, in this case, like you need to check with your own developers to ask which port is the application, whether they use a remote debugging port or not. Basically they use. If not, you can use your own debugging port address, and then you can ask the Chrome developer to communicate to that port. So now let's see the demo. So it started the Chrome dev on this port, and let's see whether it's loaded or not. Yeah, it got loaded, and yeah, that's it, guys. Thanks for watching.